Thank you. Thank you, and thank for organizer of Code Blue conference for all this stuff. It's brilliant. I'm Sergey.
I'm Alex.
And we now to speak on behalf of SCADA Strangelove security team. In working hours, we work for different security companies, but here we to introduce collective efforts to build more secure industrial control system. And this is a list of participants of SCADA Strangelove team. And I would like to ask you to give your big hands for all guys who works together with us. Thank you. So, situation with vulnerabilities in SCADA network and SCADA devices become much better since 2010 when Stuxnet worm was introduced, but still we need a lot of efforts to make more secure industrial control system. Today we will speak about power, about electricity, and I think it's very important here in Japan because, as you can see, Japan is number 5 in the list of power producers in the world. Now, power grids follows SmartGrid concept. What is SmartGrid? We have a lot of sources of energy, and we had a lot of customers who get energy and use it for their needs. And the number of generators and consumers become more and more, and we need a very sophisticated system which will interconnect each other and exchange information about number of energy generated and consumed. Why? Because we need to we cannot store electricity like we can store, for instance, oil. We need generate it instantly and instantly consume it. So, in first part of our talk, we will speak about communication issues and issues related to customers or green energy sources of electricity.
Well, the first we decided to go deeper in this kind of systems, to go deeper in our research was based on the joke in the internet, especially in Twitter. And there was a joke about where is that light that absorbs is lost forever in solar plants, solar panels. And next was that we find out that most PV plants based on the system called system on chip, one of the most widely spread system, it's called IPC at chip. Well, it uses RTOS, real-time multitasking operation system with TCP/IP stack protocols, with popular servers like web server, and it consists and uses some kind of security protocols. But we find out that simply through web interface without authentication, we can download chip configuration script. Well, one of the system based on IPC at chip, it's a solar log system by a solar log vendor, and it uses it uses a connection from inverters worldwide spread and aggregate information about distributed energy on the inverters. And simply solar log system using about 1 million inverters, which worldwide. spread. For example, in Germany, you can see the map of the connected to the SolarLock IPC chip system. There are a lot of devices, just simply for Germany. Well, how to find out these devices? Well, first approach, it's very simple, just simply using Google Docs. And we can find out Google Docs on some configuration scripts, but moreover, we can use it freely available firmware, and using simply strings, we can find out Google Docs SolarLock status. And simple direct search on the Google, we can see that about 65,000 of SolarLock inverters connected to the web, and it uses, connected to the web, and Google knows about it. Well, brief overview of the web interface give us possibility without, it's very important, without authentication, to download configuration of the SolarLock system. Sorry, not configuration, it's system backup. Well, a brief overview of system backup give us some kind of encryption of the user passwords, but as you know, and it's not just simple encryption, it's just simple XORing. Well, another one findings in the firmware update procedure was that we simply sniffing and looking at the HTTP request, we can see that we can simply replace any system file on SolarLock. Well, we coordinated with CERT and this vulnerabilities was fixed. Thanks, Sergey. Well, another one popular solar system, it's by Germany vendor SMEA, Sunny WebEx, and simply using Shodan and Google and Docs for Shodan, we can find out about 80,000 devices connected to the web. It's just only for Europe countries. Well, first findings was about 4 years ago, and it was a very popular vulnerability for this kind of devices. It's a default password. Well, it was SMEA password uppercase, but when we take a look at the official documentation for Sunny WebEx system, we find out another one default passwords. It's SMEA lowercase. Well, okay, it's just only for installer. Well, authentication process for Sunny WebEx based only on password, but without username. And based on the password, Sunny WebEx give you a kind of role. It's like a user and installer. Well, next one findings was it's not only SMEA uppercase and lowercase default passwords, but also for zeros and for ones for user and installer user groups. Okay, so we decided to go deeper and observed Sunny WebEx applications and find out. You can see on the left slide, part of slide, that it has not only user and installer roles, but also servers and developer. For what the reason to have this kind of roles? And another one interesting findings was passwords modes, like hard-coded PV. What does it mean? I think you should know about it.
So password in SMA Sunny WebEx hard-coded, very hard. But how much energy we can control with very simple vulnerabilities? The main page of this device shows the number of energy produced by PV plants. So using Google Cache, we can get this information and calculate amount of energy generated by the grid of such devices. So we able to extract from Google information about 100 of megawatts of instance power. If we will compare this amount of energy with different sources, it's like a small hydroelectric station somewhere in the Alps. So not so many. But let's speak about wind, because if solar panels consume all the sun, when wind turbines consume all the winds, and it can make disaster. So we decide to save universe again. Simple showdown search again, and with showdown search we able to find about 500 of wind devices. It's a Nordex NC2 portal, which have a long history of vulnerabilities, but still connected to internet. You can see that first vulnerabilities was found in 2010. But the root problem with this system was this based on very old web server. So it's run web server version number 3. Actual version is number 9. So Java and serverlet layer does not support it by manufacturer already, but it's still used by this system. So you can find a lot of vulnerabilities, and you can find a lot of exploits which can be used to bypass protection and get unauthenticated access to such systems. What's the difference between sun and wind? With PV plants, you work with passive device. So you have solar panel, you have inverter, you have management system and software. With wind, you have a mechanical system. You have engines, you have brakes, you have generator, and if you can manage brakes or engine, you can abuse it to make a physical disaster. So wind turbine, from security point of view or safety point of view, I think physical safety, much more dangerous than solar. Okay, how much energy we can manage in this case? Again, the root page of the Nordex NC2 portal shows us amount of energy generated by the system, and again instructed with information from Google Cache. We able to find about 1 gigawatt of instance power. Comparing with different sources, it's the same amount which generated by nuclear power plant in Boucher, which was infected by Stuxnet worm. So to break into Boucher, secret services of different countries prepared very sophisticated attack and malware. To manage same amount of wind power, you need only very simple public vulnerabilities, and you can find affected system via Google. This is scary. To resume this part, during very, very simple vulnerabilities, we able to find a way to control about 8 gigawatts of instance power. It's like a number 5 hydroelectric station, largest hydroelectric station in the world, in Brazil. So it's good amount of energy. First time this finding was presented at CCC, Chaos Communication Congress Conference in Germany. And based on feedback, we decided to establish SCADA SOS project. It's open project and everybody can contribute it. And the main goal of this project to find devices, power grid devices in the internet, to find insecurities and to inform vendors and computer emergency response team about such issues. Here's an example. One of contributors put information about insecure wind turbine configuration, about hard-coded password again, and this information was shared with computer emergency response team, and such vulnerabilities was fixed by the vendor. Also, as one of result, we able to force vendors to disconnect about 60,000 of smart grid devices from the internet. Because, you know, awareness works. If you can show, dear vendor, you have 20,000 of your customers which can be immediately hacked by a schoolboy. Please care about your customer. Next point is global radio network. Why is global radio network so important? Radio network now used everywhere, in ATMs, in SCADA, in our everyday lives. But radio network have a very huge attack surface, so you can attack it via different vector. Now it uses TCP/IP protocol, so you can use your favorite attack toolkit to find and exploit vulnerability. And what's important, it's global. So if you have vulnerability in mobile carrier somewhere in US, you can use these vulnerabilities to exploit mobile carrier in Japan. Why? Because it's interconnected. Let's give an example. One of the simplest way to find vulnerabilities in mobile carrier network, it's use of vulnerabilities of IP boxes, of IP routers like GGSN, SGSN, because in general, it's IP devices with standard management interfaces, and you can find unsecured interfaces like Telnet, SNMP, etc., and exploit it. Sometimes customer use private APN. APN, it's connection string for GPRS, which well known for different carrier, but sometimes you can use private APN, which unknown. And many people believe that this kind of VPN. But in general, this is wrong. APN can be easily guessed, and use it with private connection string. You can get access to different IP connection via mobile network. Another point is 4G radio security. Theoretically, we believe that current level of encryption for LTE is okay. So good ciphers, strong encryption, authentication, but on practice, many mobile carriers support backward compatibility with 2G networks. So if you can mount man-in-the-middle attack, so if you can be a fake base station, you can downgrade authentication and encryption level and intercept any communication. Carsten Noll on CCC demonstrated that in many countries, encryption is prohibited by law. So even 4G network runs unencrypted. But in many countries, even if encryption is allowed, 4G encryption only is prohibited. Why? Because secret services need have ability to downgrade encryption level to lawful interception, to catch bad guys, I think, terrorists, etc. But other guys can use this ability to downgrade encryption level and intercept communication. Another interesting point, it was presented here in Japan last year. It's advanced vulnerabilities in SIM cards. I think you know that SIM card is a computer running Java. So if you can find vulnerability in application running on this chip, you can abuse it and exploit. And it was demonstrated how via special crafted SMSs, you can obtain encryption keys and TMC, which stores on the SIM card, or even install special crafted malware, special crafted Trojan Java applet on the SIM card, which will survive mobile handset changing. So if you change your phone and install this SIM card in different phone, you still will be infected. One more very interesting area of security research is security of femtocell. What is femtocell? Femtocell is a small broad-based base station, mobile base station, which you can use to extend coverage. So you can install femtocell in this room to have good mobile coverage. But in most cases, femtocell is just a Linux box. If you can root it, you can intercept all communication between femtocell and mobile carrier. So you can mount man-in-the-middle attack for 3G and 4G network, because all communication will be decrypted on the femtocell radio communication. You can intercept it, and after encrypt it, and through the IPsec tunnel, submit to the mobile carrier. It was presented in different conferences, for instance, in Black Hat US 2015. Another interesting topic presented by our team, it's vulnerabilities in 4G modems. It's a very common device. You can plug in your laptop and get access to the internet. But in most cases, 4G modems, it's very sophisticated piece of software and hardware. It have different interfaces, it have storages, so you can hack it. So let's try to guess how we can use vulnerabilities in 4G modems to get access to hosts which use this modem for internet connection. Take control. Here's an example. So this modem was virually hacked, and firmware was updated. After connection, it starts to work as a network device. And this is OK, because this is a modem. I'm sorry, Huawei. But after timeout, this device become a keyboard. And obviously, keyboard can't type. No hands, but somebody typing with our modem. As a real hackers, it's launch calculator. After it gets BIOS specification to understand hardware specification of the laptop, and reboot the computer. During reboot, this modem became a CD-ROM drive. Why? To boot this computer from the CD-ROM. And during boot, it installs bootkit on this system and can bypass any security features on your device. We have a question for you. First one, who guess how to bypass security BIOS using this attack? Because now many laptops and devices have security features and BIOS. Will get special prize from SCADA Strangelove team. So let's imagine that we have a password on the BIOS. So boot from the BIOS from the USB will not work. But how to bypass this protection? Any guess? Come on, it's not a school. Okay, BIOS is software. It interacts with different devices. To interact with devices, we need in computers, piece of software to interact with devices. It's a good. And driver have what piece of software? Any piece of software? What? Bugs. Excellent. Your prize is yours. So drivers have bugs. So BIOS have drivers for hard disk, for keyboard, for mice, and nobody care about vulnerabilities in driver of the mouse. Why? Because how to exploit remotely vulnerability in mice driver? Easy, via bad USB. So it's huge attack surface. Printer drivers, mice drivers, file system drivers, etc., etc. Travis Goodspeed and Sergey Bratus had a good research on this, but they think about only local exploitation of such vulnerabilities. But such vulnerabilities can be exploited remotely. Sometimes it can be exploited via internet. It's again, simple showdown search can help you to find a lot of 4G modems which have web interface available via internet. So how it's related to, okay, thank you. How it's related to SCADA security? Obviously, many industrial systems use special devices, wireless modems, wireless routers to connect to central point, management point, etc. And obviously, these vulnerabilities can be applied to such system. But this topic for our next talk, maybe on next conference. Alex?
Well, a few steps back to the smart grids, to wind turbines and engines. And anybody already see the movie Black Hat? It's this year Hollywood movie. Well, if somebody didn't see it, please close your ears or disable your translator device. I'm going to give you a short spoil about that movie. And at the beginning of the movie, there evil guy push the button enter on his laptop and send some packets to a big strange engine machine, and as a result is going to big physical disaster. Unfortunately, from our experience, it's a real scenario. Everybody knows that about Hollywood, fairy tales, Hollywood, but as I said, from our experience, it's a real type of attack because it's based on the simple protocols which can increase or decrease speed of turbine, of wind machine and big heavy machine engine and so on. Simply one, for example, UDP packet can change the physical system. Well, what about SCADA connected to the internet? What about radio antennas and so on? We find out an article in some journal called Gamification of Agent-Based Smart Grids. Well, gamification, what does it mean? We was really impressed about this article, and the main idea was to connect all of the energy system to some kind of social network and to create this powerful social network. And the main idea was to get possibilities for users to send with some kind of social network. It's nowadays it's like a cloud network, to send the data about power generation and exchange between other users.
So you can show your neighbor, look how many energy I generated. I am save the I don't know, oil, so I'm good guy. Why you generated so not so much? Let's work together to generate more energy and more. But this have a back side. This approach have a dark side. Sorry.
It's bad approach, and following to Sergey idea, previous century we was proud about our big trucks, a lot of money, but nowadays we should proud about how much energy we produce. And so it was an idea to distribute SCADA system to the cloud. Well, and one of the system who going to this idea, it's SolarLog. SolarLog portal get connected a lot of devices to this system. And well, simply it's a web-based system, web-based portal, and there are the same as another one, web systems vulnerabilities. Well, one of the vulnerabilities give as at the end as a result is give evil guy possibility to create back connect to the home smart grid system, and in this case it's remote code execution, and evil guy just simply hack a cloud portal, can connect to all devices. What about patch management?
Yeah, this sometimes to find vulnerability is the easiest part. Also, after this, as a white hat, you should fix it or force somebody to fix it. And sometimes it's create troubles. For instance, when we first find vulnerability in SolarLog, we tried to reach the vendor. Vendor doesn't return any response. So we try to coordinate our activity with ICS-CERT. It's US-based computer emergency response team. But we get a response that it's not interesting for them because this system not distributed in US. So we connected with CERT-Bund in Germany, and thanks for them again for coordination. But in several months, we found that General Electric will integrate solar log system in smart meters. Why it's important? Because smart meters share information about amount of energy generated by PV plant, not with the grid only, I mean grid like a cloud, but with power grid also. So you can full power grid of the country. You can spoof amount of energy generated or consumed by this installation. For sure, one PV plant generates a very small amount of energy, few kilowatts only. But if you can control thousands of plants, you can spoof gigawatts of power, and you can fool the system and manage it to change power flow in wrong direction. Just for demonstration, it's a short circuit on 10 kilowatts cable. It's like looks like 10 megawatts. So it's only few towers in the city. I'm sorry. So after the talk, we have a conversation with German electricity engineer, and he told us that European power grid have only 3 gigawatts of buffer. So if you can full management system for 3 gigawatts, you can make the situation when lights will go out for a long time. So this is scary. Next, we will talk about digital substations.
Well, for digital substations, one of the important part of security, it's relays.
Relay protection.
Relay protection. It's kind of protection when something happen bad on the left side from this picture, and relay protection close any connections, any physical activities between energy distribution melts. Well, it's kind of firewall between problem side and between real life side. Well, for relay protection, it's based on IC61 family protocol, and we did deep research about these kind of protocols and created some toolkits to play with IC protocols. And next is our activity, how to find vulnerabilities, how to create community, to give possibilities participants to find out vulnerabilities. One of the first is open laboratory at Positive Hack Days. It was on Positive Hack Day 3, and it's called Choo-Choo PVN Laboratory. It was a simulation of railway stations, trains, and so on. Next one was at Positive Hack Days 4. It called Critical Infrastructure Attack, and the main idea was to find out zero-day vulnerabilities And the goals was not only find out vulnerabilities, but also make a disaster and create some kind of practical tools, practical impact, and so on.
Toy disaster, not
Yes.
real disaster, yeah.
Yes, exactly. And there was some targets, very popular, and ICS systems like Schneider Electric, Siemens, Rockwell, and so on. Well, after PhD days 4, we got a lot of interesting vulnerabilities, and only for 2 days we got more than 10 zero days. And one of the winners was Alisa from Message Lab. She found out binary vulnerabilities, a lot of vulnerabilities in Schneider Electric software. Well, and of course, these vulnerabilities we share following by response disclosure policy. And also, next one, and this year was Positive Hack Days digital substation takeover. It was quite interesting, but how to say? It was
Challenge?
Yes, exactly. Very interesting challenge for participants, and sorry. And the main result was to make disaster on the cable melt. Well, there are another one, vulnerabilities.
So it was a real hardware, but toy power. And the goal of participants was to find the way how to make a toy disaster. And you saw the grid overload, which was created using vulnerabilities in Siemens C-Protect system. Part of vulnerabilities already fixed by the vendor.
Okay, and we know that especially for Japan, energy it's very important. It's highly important part of your life. And on internet we can find out the map of energy stations. And one interesting information about energy stations, it's how much energy they produce, and also location of this station. Well, following this information, we found out some solar plants, and the picture you can see Yukishima, and also Kagoshima solar power plants. Well, what about Kagoshima? It's created by Kyocera, as I know, and with SMEA vendor. SMEA created Sunny Central big station, and in diagram you can see how Kagoshima plant works. And as you know, and SMEA very interesting vendor, and we find out some vulnerabilities and SME software and devices. Kagoshima produces about 70 megawatts of energy. Well, and as we mentioned before, SMEA products has simple vulnerabilities like hard-coded passwords, accounts. And this information public, and we shared with this information with Japan CERT. So we hope, if it's important, these vulnerabilities will be fixed or already fixed. One additional point, it's number of SCADA system connected to the internet in Japan. We able to find more than 600 of different SCADA PLCs, RTUs, and most of them use open protocols, like industrial protocols, I mean, like Modbus, like S7, and this is not very good. Why? Because such protocol does not have any security features at all. But this information shared with certs, and I think it will help to secure such system.
But anyway, now it's look like this. Postscriptum. When you're working with industrial security, you need to have engineering mindset. I have one more question for you. Which picture is bad? Number 1 or number 2? On number 1, we have yellow signal. On number 2, we have green signal. Which? Raise your hand. Only 2 guesses. It's easy.
One of 2 can get a prize.
Yeah, I have one more prize. Okay. 1 or 2? Please, anybody. 1. Okay. You're wrong. But anyway, you will get a prize. The bet is 2. Green light. Why? I will show later. One more example. We have super heavy trains. It's trains which use several engines and radio channel to coordinate activity. And many people believe if you encrypt the radio channel, it's safe. But in general, you don't need to intercept encryption. You can just jam it. And after the jam, engines will work in the wrong manner and you can have a disaster. One more example, it's when you talk with industrial engineers, you often can listen something, okay, our system is Seal4 certificate. It's safe. It cannot have any disaster. And frankly speaking, what is Seal4? It's a certification for probability of failure per hour or on demand, and this is very small number. So this system must be safe. But if you can get remote access to this system and obtain root access to this platform in several minutes, you can make everything. You can upload firmware, you can patch execution way, and no seal level anymore. But people still believe that computers, it's a small relays. No, it's a computers. It's managed by software. So now we know that the green light is bad. Why? Because according railway rules, green light allows to pass the station on the maximum speed. But we have a yellow line. This is road. Road is located on the sideway. And on the sideway, we have a curve. We have a switch. And if train will go on the maximum speed on the curve, it can get out of the train. So you need to understand not only technical vulnerabilities, but also vulnerabilities of technological process to understand what you need to protect. One more postscriptum. Several years ago, we saw network convergence approach in different networks. So we use same technology at the moment, we use TCP. But what we see at the moment, we call it operation technology convergence. So when different operation technologies like SCADA, mobile carrier, payments, Internet of the Things, cloud, use it for different systems like SmartGrid, like public transport, like smart city. And vulnerability in any of these can create a disaster. More, it can create chain effect disaster. So for years, we speak on different conferences with different topics about ATM security, about communication security, about trains vulnerabilities. The goal is to demonstrate reverse perimeter. What is reverse perimeter? It's a concept when vulnerabilities of the air-gapped device can create big disaster, because people still think that these such devices are air-gapped, but on practice, no. One example, you see a guy and ATM. And this very good ATM because it gives money to this guy without any interaction. Man gives it takes the money, sends SMS, and the ATM will give additional money to him. With a real forensic tape from Carbanak robbery, when cyber criminals able to stole about 1 billion of USD using different vulnerabilities on payment software. How it works? Why this ATM share money with these guys? Okay, let's go use Google again, sorry, Shodan, and let's try to find ATM on the internet. It's amazing. Internet, ATM? Yes, but we can't find it. It's not a challenge. It's NCR terminal running on the top of on Windows 2000. Anybody here have trouble to find vulnerabilities in Windows 2000? So thank you.
Some people call them terrorists. These boys have simply been misguided.
If somebody has questions and interested in our research, just feel free to ask us during conference, or feel free to stay in touch via email, on Twitter, and so on. And again, thank you so much.
And also we have prizes, don't forget. 1, 2, yep. Questions, please, if you have a time.
質問あります方、挙手をお願いいたします。
Sir.
ありませんか？
Any questions about how to get access to trains, railway stations,
Or to secure it.
or money from ATM?
いかがでしょうか？
No questions.
No questions?
No. I think it
はい、
was
それでは
clear.
終了させていただきたいと思います。Thank you, Sergey.
Thank you so much.